Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other lists as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my two circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900. And that's it. So our answer is 9,900. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3, and then when you multiply them together you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19, and we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include a, s, v, and u? That's got a t in it, that's got a t in it, so it's going to be this one here. Let's write that out. V squared equals u squared plus 2as. So that would be 34 squared equals u squared, because that's what the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals u squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. There is quite an easy way of doing this question, but I'm going to show you the long way and then we're going to work out what the quicker way is. So I'm going to pair up the A and the 1, which it suggests in the question. Then I'm going to work out the A and the 2 as a different combination, A3, A4, etc. Then I'm going to look at the B and do the same thing, B1, B2, B3, etc. Then I'm going to work out the C, so all the combinations with C. So how many combinations are there with A? Well, there's going to be 7 because there's 7 numbers. How many with B? Well, there's also going to be 7. And how many with C? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 900700000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. So we're given 21 to 4 is the ratio. We're just going to have our lines in, because what we need to do is make the left-hand side be 1. Okay? And to do that, for 21, I need to divide it by itself, divide it by 21, and we're going to do the same to the right-hand side. So 21 divided by 21 is 1. Perfect, that's what we wanted. 4 divided by 21 is 0.190, blah, blah, blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. The first thing we need to do is work out the area of the floor. And you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h. And a and b are the parallel sides. So these ones are the parallel sides. And the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are soldering packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence. So I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chilton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chilton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chilton at 9 o'clock. He drives from Chilton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed distance time triangle. So speed equals distance over time, and we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. So we know that the exterior angle is equal to 360 divided by the amount of sides, which we can just call n. And something you can do is actually just swap these two things around. And we can say that the n, the amount of sides, is 360 divided by the exterior angle for a regular polygon. So we just do 360 divided by 5, and that gives us 72. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. So the formula we need here is that the sum of the interior angles is equal to the amount of sides, take away 2 times 180. So we know that the sum of the interior angles is 2160. And we're looking for what n is. So we're going to do a bit of solving. Not too difficult. We're going to divide by 180 both sides. And that will give us 12. And then we're going to add 2 both sides. And that would be 14. So the amount of sides is 14. Factorising is the opposite of expanding. So instead of removing things from a bracket, we're actually putting them in a bracket. And so we're going to start off by just putting the bracket down. And we're going to think, well, what can we put on the outside? So we look at the 20x squared and the 35x. And we first of all think of the number. So we're looking for the biggest number that goes into 20 and 35. Essentially, its highest common factor. Well, that's going to be 5. And then we look at the letters. So we look at the most amount of letters we can divide out. Well, this only has an x here, so it's just going to be an x. Then what we're going to need to ask ourselves is 5x times what is 20x squared? Well, 5 times 4 is 20, and x times x is x squared. Then to get the second term in the bracket, we ask ourselves, what times 5 is 35? Well, that's going to be 7. And what times x is x? Well, we don't need an x on the end of that. 5x times 7 is 35x. And you can actually expand that, and you can use any method you want. I'll use smiles and rainbows. And so we're going to do 5x times 4x, which is 20x squared, and 5x times 7, which is 35x. So our answer will be 5x brackets 4x plus 7. So we've got a right angle triangle, and we're given 2 lengths, and we're asked to find a third length, and that means we're going to be using Pythagoras' theorem. And to do that, we're just going to label the sides A, B, and C. And C must be the hypotenuse, which is opposite the right angle. Pythagoras' theorem says that A squared plus B squared equals C squared. A we can see is 3.4. B is 5.2. And we're looking for what C squared is. So 3.4 squared plus 5.2 squared is 38.6. And we need to solve to find out what C is. And to do that, what we do is we just square root both sides. So square root of 38.6 is 6.212 blah blah blah. And C squared, the square root of that is C. So it's 2 decimal places, it's going to be 6.21. Whenever we solve, we've got to get rid of any fractions or brackets first. Now looking at this, there's no fractions, but there are 2 sets of brackets. We've got the set of brackets here, and we've got the set of brackets here. So we're going to expand them to get rid of them. And you can use any method you want. I'm just going to use this kind of grid method. So we're doing 4 times, and inside the brackets we've got 3x plus 5. So I'm going to times those out. 4 times 3 is 12, so that'll be 12x. 4 times 5 is 20, so that's going to be positive 20. And I'm going to do the same for the other set of brackets. Now on the outside of the brackets we've got to be careful here. It's not a 5, it's a minus 5. And inside the brackets is an x and a 2. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. So when we put it all together, we get 12x plus 20 minus 5x minus 10, and then the rest of it is just equals 52. So I'm going to start by putting my lines in because we're solving. And I'm actually just going to start by collecting the like terms on the left hand side. So 12x take away 5x is going to be 7x. And 20 take away 10 is going to be 10. Okay, now we need to get rid of the plus 10. So we'll take away 10 both sides. So we've got 7x equals 42. And then we need to get rid of the times 7. So we're going to divide 7 both sides. So x equals 6. To work out the area of this prism, we need to first of all work out the area of the cross section, which is this part here. So this triangle here. So to do that, I'm going to do half times base times height. So it's going to be half times the base, which is 22, times the height, which is 14. That gives us 154. So the volume is the area of the cross section times the length. So the area of the cross section we've just found out is 154, and the length is basically how 3D the shape is. So that's going to be 15. So the answer is 2,310 centimeters cubed. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the graph, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. To find the gradient of a line, we need to find two coordinates that we know. So I've got this coordinate here and this coordinate here. Now I don't really know what this coordinate is, that's why I've not picked one. You need to pick coordinates you know. And what we do is we just draw a right angled triangle between them. Try to get this nice, there we go. And the gradient, which we call m, is the change in y. How much has y changed over the change in x? So the change in y is going to be 4, because it's gone up 4, and the change in x is 3, because it's gone to the right 3. So our answer will be 4 over 3. The parts of a box plot are that the lowest value is on this side here. The lower quartile is this bit here. The median is this bit here. Upper quartile, and then the highest value. So the median is this part here, and we can see that is at 23. So the median is at 23. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. So first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. Alright, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. And so it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25. Take away 4 times 8, which is 32, is minus 7. So we know we've got it right. It's sometimes easier in these questions to view these triangles as 2 separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got 2 triangles here. We've got a big triangle and small triangle. We can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the 2 triangles are similar because the sides here we assume are, well, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A. And so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20, and then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do, but I think this is a really tricky question to do without a Venn diagram. So it says that they picked 2 activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as x, then the sport will be 2x. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2x, take away the 11 that we already know about. And the painting is the same. We know the whole thing is x. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be x minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So x minus 11 plus 11 plus 2x minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got x plus 2x, which is 3x. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. I'm going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. When solving simultaneous equations graphically, if you draw the lines to both graphs, which we have done here, the solutions, or solution, because they're both linear, will just be where the two graphs cross. So this here will be our solution. So x is 2 and y is minus 4. The arc is a section of the circumference, and I'll show it on the diagram here. This is the arc. And to find the length of the arc, we use a simple formula, and I'm just going to explain what the formula does. So the arc length is equal to the fraction of the circle that you've got, and we times that by the circumference of the circle. Now to find the fraction of the circle we've got, we work out the angle of the sector and we divide it by 360 because there are 360 degrees in a full circle. Times that by the circumference, and circumference is just going to be pi times the diameter. The angle is 61 degrees. Now the diameter, if you imagine that the circle is all the way around, so it's a full circle, you can see the 6 centimeters here is the radius. So if we carry that on, there'll be another 6 centimeters here, so the diameter will be 12. Just 2 lots of the radius. Type that into a calculator and we get 6.387, blah blah blah. And it says it wants it to 2 decimal places, so when we round that it comes to 6.39. So vectors are shown with how far right at the top and how far up at the bottom. So we've got -3 right, which is actually going to be 3 left, and -2 up, which is actually going to be 2 down. So to start this off, what we're going to do is just put a point anywhere on this grid, and we're going to go 3 right, so 1, 2, 3, and we're going to go 2 down, so 1, 2. Let's show that point there, and then all we need to do is join up these 2 points with a straight line, and we need a direction. So we actually started at the top right one and went to the bottom left one, so the direction is going to be this, and it says it's vector A, so we're just going to label it with an A. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100, so that would be 65%. When asked to simplify a fraction, we need to find a factor at the top and the bottom to divide out. So with this question, we're going to start by factorising the top and the bottom. I'm not going to go into how to factorise in this video, but the top will factorise as x plus 2, x plus 4. And we've got videos on how to factorise quadratics if you're not quite sure. And the bottom will be x plus 9, x plus 4. Now it's not a coincidence that we also have an x plus 4 at the bottom, because that is the factor which we're going to divide top and bottom by. So we're going to divide top and bottom by the x plus 4, and that will get rid of the x plus 4 at the top and the x plus 4 at the bottom. It actually won't get rid of it, it will just turn it into 1, but x plus 2 times 1 at the top is just x plus 2, and x plus 9 times 1 at the bottom is just x plus 9. So we know these cuboids are similar, so they're going to have a scale factor, and we can work out the linear scale factor, and to do that we've got to work out what we times 17 by to get to 161.5. So we'll do 161.5 and divide it by the smaller one, which is 17, and that's 9.5. So the linear scale factor is 9.5. Now this is all about volumes, and we're told that the smaller volume is 85, and we've got to work out what the larger volume is. So to work out what a volume scale factor is, what we do is we cube the linear scale factor, because in a volume there's 3 dimensions, so we're going to times it by the linear scale factor 3 times. So 9.5 cubed, so the volume scale factor is going to be 857.375. So we're times anything, or any volume, by that, and it will give us the larger volume. So we've got the 85, and we're going to times it by 857.375, and we get 72876.875. So notice it's a lot larger. Yes, the linear scale factor's gone up by just under 10, but you look at how big that volume is, and that's generally what happens. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. So we first of all need to work out the frequencies in each of the bars, and we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total. And they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, so we can just round that to 11. We're going to first of all work out the frequencies for each of the bars. So we're just going to do the class width times the frequency density. So for this first one, it's going to be, 1.2 times 10, which will be 12. 3.2 times 20 for the next one, that will give us 64. And the last one will be 16. So 20 times 0.8. Okay, add them up, check it equals 92, which it does. Now to find the position of the median, we're going to do n plus 1 over 2. N is 92, so it's going to be 92 plus 1 over 2. And so that's going to be 93 divided by 2, which will be 46.5. So the median will be in the 46.5th position. Okay, so where is 46.5? Well, the first 12 are in the first bar here. The next 64 are in the next bar here. Now 46.5 would be in that group. And whereabouts is it going to be in that group? Well, what we're going to do is we're going to take away the 12 because they're in the first group, and it is 34.5th in that group. So if there's 64 in total, it will be about here. Okay, so the frequency will be 34.5. So there will be 34.5 of them in that group. So what fraction in that group is it? Well, the fraction will be 34.5 over the total frequency in the group, which is 64. And so you work that out on the calculator, so divide that by 64, and you get 0.539 blah 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 blah. Okay, now we've got to work out, we're not really interested in the frequencies, we're interested in what this distance here is. And so the total distance in the group is 20, the class width of the group. And so we want to find out what the 0.539 blah 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 times the total class width is. So we're going to times that by 20, and we get the answer of 10.78125. So this is going to be 10.78125 down here. But we need to add it on to the 10 that we have already. So we've already got 10 there. So we're just going to add the 10 and the 10.78125 together, and that will obviously give us 20.78125. And it wants its 2 decimal places, so it's just going to be 20.78. So we're given the equation of the line, which is y equals ka to the power of x, and we're given two coordinates. So we're looking at this first coordinate and put that into the equation. So y is 10 equals ka to the power of x, which is 1. And we're going to do the same with the other coordinate. So we've got 40 equals ka to the power of x, which is 3. Now look at what's happening to both sides. Here we're multiplying by a squared. So a to the power of 1 times a squared is a to the power of 3. And on this side we're multiplying by 4. So we have to be able to conclude that a squared equals 4. And if we square root both sides there, a must equal 2. So if a equals 2, we can just put that into the first equation here. So we've got 10 equals k times 2. And divide both sides by 2, and we get 5 equals k, or k equals 5. So our answers will be k equals 5 and a equals 2. Now check that works. So let's have a look at this second coordinate, and we're going to do y equals, and we're going to do 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. So we know that our equation works. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9, and all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So the first thing we need to realise is that we can create a right angle triangle from within this cone. So if I draw a line from the top going downwards, a line to the right and a line up, and we can label the sides. So we've got 30 here and we've got 10 at the bottom here, and we're looking for this angle here, which we're going to call y. And if I just highlight all of this and move it across, then we're obviously going to be using trigonometry to find out what y is. So first step with trigonometry is, well, find out where the right angle is, which is there. And the one opposite the right angle is the hypotenuse. The one opposite the marked angle is the opposite. And the one between the right angle and the marked angle is the adjacent. In this question, we're not using the hypotenuse because there's no letter or number next to it. And so I'm going to do my SOHCAHTOA, SOHCAHTOA. And we're not using the H, so we're going to cross out these two. We're using the TOA, and that stands for tan the angle, which in this case is y, equals the opposite, which is 10, over the adjacent, which is 30. And so tan, so we're going to inverse tan both sides, so we're going to have to solve this. Let's get my lines in. And we're going to inverse tan both sides. So that will just leave y on the left hand side, and then we need to find out what the inverse tan of a third is. And the inverse tan of a third is 18.434 blah blah blah. Now, what I did at the start was I moved the diagram away from the cone. Let's just move it back and we'll see the fact that y is exactly half of x, because we've done a line straight down the middle. So to find out what x is, all we need to do is double y. So x is going to be 2 times y. So that's going to be 2 times the 18.434 blah 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 blah. And so that is going to be 36.869, etc. And it says it wants it to correct 2 decimal places, so that's going to be 36.87 degrees. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3, and it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. So here we have a cube and we're asked to find length BH. Now there is a simple formula for us to be able to do this, but we're going to pretend we don't know that formula and then maybe we'll talk about it at the end. So we're going to split this up into 2-dimensional triangles. I'm going to start with a triangle down here. Let's just draw that triangle in. And we've got 3 at the bottom. Now we actually have 3 down this side because it's a cube, so all lengths are exactly the same. And we're looking for length FH. We know we're going to use Pythagoras for it. because we've got a right angle triangle and we've got two sides and we're looking for the third side. So that's going to be EH squared plus EF squared. Let's get our tram lines in. So that's going to be 3 squared plus 3 squared, which is 9 plus 9, which is 18. Square root both sides, find out what FH is, which is going to be 4.242 recurring. We could have left it as square root 18. Okay, next thing we're going to do is we're going to create another triangle. We're looking for BH, so we're looking for this one here. So we're going to create a triangle like so. And let's draw it in as a two-dimensional triangle. Now again, it's a cube, so this length here is going to be 3. We've just found the bottom one, which is 4.242, blah, blah, blah. I'm going to keep it into my calculator so I can have some precision. And we're looking for BH, which is this one here. So we're going to be using Pythagoras again. Why not? Okay, get my tram lines in. Okie dokie, so let's put FH in, which is that 4.242 blah 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 squared. BF is just 3, and that will give us exactly 27. And then we're going to square root it, and so we've got BH equals 5.196 blah blah blah, and it says it wants its 2 decimal places, so it's going to be 5.2. Now really, because it says 2 decimal places, we should write the 0 as well, even though obviously 5.20 is just the same as 5.2. But if it asks for 2 decimal places, we'll keep it to we'll always keep it to 2 decimal places. Now there is a formula that we can try out, and that formula says that when you've got this situation where you're looking for the diagonal of a cube or a cuboid, you can square all of the sides, and it's kind of like a mega Pythagoras. So if I get my calculator now and type in square root of 3 squared plus 3 squared plus 3 squared, and then press equals, I get exactly the same answer. So this formula here is actually quite useful, and if it's something you want to look into just to save a bit of effort with this question, feel free. But you do need to know the triangle method for when using trigonometry later on, and for kind of advanced questions on 3-dimensional right angle triangles. So you just need to make sure you know both methods, but if you want to use that quick shortcut method, feel free. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in, it's not a problem. So we can just rewrite this function as y equals x over 10 minus 11, and we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides, and I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation, and we get 10x plus 110. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.